So we're going to continue on. We've got our basic Metro patch. I'm going to take a few things out that are kind of not being used. Durations over here, speed. Um, we know what's happening with the Metro, so let's take out that print. We know what's happening with the make node, so let's take that out and try and get just a little more focused on the patch. What's going on? So first thing I want to show you is a handy message. It's called set, and it's going to update the number box, but it's going to tell the number box to hold on to its value and not output it. So I'm going to break the patch between the node in strip node to number and type in a message. So an M gives me a message box. I'm going to say set and $1. So $1 is just a variable. It's telling the message box to take the input, the first item in a list. That's why the 1 is there. But it's telling it to take the input. It's only one item. And replace the $1 with the input. So the whole message that goes out, let's hook this up to a print so you can see. Let's clear this. The message that goes out, if I type something on the MIDI keyboard, play something, is you see set 60. Now if I send that over to the number box that is MIDI pitch, and I play something on the MIDI keyboard, which I'm doing now, you don't hear a note. It's updated. Let's change again. You can see it update, and you can see that change, but nothing is coming out because I'm using the set message. So this means if I update the pitch while the metronome's playing, you're not going to hear it. You're going to hear it at the next bang, so I don't affect this rhythmic pattern of notes. Okay, that's useful in a musical setting. So I can update my information, but it doesn't immediately play. I keep my rhythmic pattern going. All right, fantastic. So we're going to use that a lot. Keep track of this part. Now let's do one thing. We're going to add one more thing onto here to get a little variation. And it's going to be essentially just junk variation at this point because it's going to be randomness and it's not going to be controlled or mapped into any sort of way. But this is a start. So instead of just banging the note that I set, let's add a random object. Let's say 128, which is the entire MIDI pitch range. And into this. And now, if I start, it's even better when it's fast. Not really. But I've got some more pitches now. I can always useful to kind of constrain that. So I'm going to do that right away. I'm going to take a number box, put that into the right inlet, and let's say we're going to make it random within an octave. And now it's going from 0 to 11. And this is very important in a computer concept. If I give a range of numbers as an argument, like 128 possible values, the first value is always going to be 0. The highest value will be the argument minus 1. It's just the way computers count. Computers count by starting with 0. So I'm getting 0 to 11 right now. If I wanted the full octave, I'd actually need 13 steps to get, say, C to C. All right, so that's in a really unuseful range. You can't really even hear pitch deviation. So what could make this more useful? So many things, but a simple thing would be making some more room, inserting a bass note with add. And let's add first, we'll always make it start with middle C. So that's kind of a default value. And now this is going to give me want to show you what's coming out. So 0 to 12, and then get 60 added to it, and that's what's getting sent to make note. So what I can do to finalize this, make it a little bit better, is instead of sending this as just the note, let's send my MIDI keyboard, I'm going to play bass notes of my random range to apply to my random range. I'm offsetting the random. So I'm setting up a range, 13 from 0 to 12. I'm offsetting it by this amount. That gives me a final value. So let's send my offset, get my offset from the MIDI keyboard. And I'm going to move it down an octave. Wrong inlet or type. So at this point, I don't need the set message. So I'm seeing this red here. It tells me I did something wrong. This inlet doesn't expect a message, it expects a number. So break. I'm going to keep this just so it's there. But really the number can just come in. And because the right inlet does not send out a value, it's storing the value to add to whatever the left inlet gets and sends out that number. I don't need the set message anymore. So that's what that's meaning. I'm going to erase that so I think I got it right. And this points out a little bit of something that's sort of the usual order of the way Max works. Since Max works on, sends information out in a right to left order and executes things in a right to left order, right inlets to the right of the first one are going to be cool. And if I mouse over them, you see little blue rings pop up. Okay. So cool means messages, values come into the object stores them, but it doesn't trigger a computation or an output. Hot inlets, are the left most. So messages in the left cause the object to do its computation, whatever it is that it does, and send out a value. So this cool inlet stores my note. When it gets a number from random, they add together, sends an output. So now, it was still operating on 60. Moving it down again. Move it up. So what I've just showed you now is how to have randomness, how to restrict the range and provide an offset, and how to get that offset from the MIDI keyboard so that you're playing random notes above some key that you've pressed on the MIDI keyboard. And that's a good stopping point. On Friday, we're going to make some more noise. Great.